Hello, today I want to solve Matt Parker's maths problem, which is about string of primes. So, what we want to do is to sort numbers from 1 to 9 in such a way that the sum of any two nearby numbers is a prime. Okay, so we just can try to rearrange them and see what happens. But I think we can see a pattern, and I would like to propose a way to solve this problem, even if the numbers are not up to 9, but they are up to another, let's say, odd number, but actually the method I'm going to show can be extended also to up to an even number. I am not sure that the problem is always solvable, but I strongly think it is for any number you choose. So, let's start with a remark. Any even number greater than 2 is not prime. That's easy, it's even. Hence, two nearby numbers must be of different parity. So we want to sort numbers in such a way that the sum of the two is odd. So we have 5 odd numbers, we have 4 even numbers. We want to have our sequence, which is odd, even, odd, even, odd, even, and so on. And so I'm just writing a plus table of odd numbers plus even numbers and check what their sum is. I'm putting in green the primes ones and in red the ones that are not primes. And that's it. It's quite easy if you do like that, because you see on the diagonals you got, of course, the same sum. And so we want to find this odd, even sequence. So all the green sums are what is fine. And what we have to do is notice now that each even number and each odd, apart from two odd numbers, is into couples because it's in the middle of the sequence. So we are going to highlight two cells in each row, so two cells for each even number, and two cells in each column, apart from two columns which will be taken only once, and that will give us the string. Let's see how. We just highlight 1 plus 2 and 1 plus 3 and 2 plus 3 and the others. Okay, so we notice that in each row we've got two highlighted numbers, and in each column, apart the first and the last, we've got two highlighted numbers. Exactly what we want to do. And this is exactly one sequence. Actually, it's two sequences because you can read it from one way to the other. Which sequence it is? Well, you have to start either from the cell 1 plus 2 or from the cell 9 plus 8, which is one which is lonely, which is only have a neighbor. And this one tells us that the odd number is 1 and the even number is 2. Next, we move. We must have 2 and another odd number. In the row 2, we've got the other highlighted number, which is the one you get by adding 2 and 3. And so you got 1, 2, 3. Now I move the giant cell to the 2 plus 3, and so on. Then you move to 3 plus 4. Then you move to 4 plus 7, and so on. So 1, 2, 3, 4, 7, 6, 5, 8, 9 is the solution. Of course, also reading backwards, 9, 8, 5, and so on is also a solution. So it's quite easy. You just have to do this to write this table, which is quite easy. Paint in green all the numbers which are primes, and then you have to choose 2 in each column, apart from 2 columns, and 2 in each row. And then you've got the string. Let's see how. So let's say we want to do the same for another arrangement of numbers from 1 to some odd number. Let's say from 1 to 23, which is quite big enough. You just arrange all odd numbers and all even numbers. You take the sums and you put in green all the ones which are primes, all the sum which are primes, which are the ones that are okay. And so what you do next? Next, you just have to enlight two cells for each column, except for two columns, and one cell in just two columns, and two cells in each row. That's quite not too difficult to do. Example, grazie a this, which gives you the sequence 5, starting from the blue one and ending in the red one, which are the ones, the columns which have only one cell. It gives you the sequence 5, 2, 1, 22, 21, 20, 23, 18, 19, 12, 17, 14, 15, 16, 13, 10, 9, 8, 11, 6, 7, 4, 3. But this is just one of many possibilities. There are really a lot of possibilities. I think this is a way that it's worth use to visualize this problem. And I think it should be possible to solve this problem going from 1 to any number, both even or odd. But I have not proved it yet. Can you do that?